Hello and good evening to everyone. Welcome back to another session on Resultant JE YouTube channel. I'm Vikas Sir. I welcome you all to this mechanical practice session where I'm going to discuss most important questions on thermodynamics and applications. Good evening all of you. Welcome to once again on this YouTube platform of Resultant where I'm back again with some mechanical questions important for RRB JE 2024 exam. And as you know that CBT1 exam of RRB JE, the tentative schedule is out now, will be conducted from 6th of December to 13th of December 2024. Okay, so I hope you must have seen that video that hello MS, good evening. RRB JE CBT1 exam will be conducted from 6th December 2024 to 13th December 2024. So guys, it's a very important update. This is a tentative date, but be ready for it. Okay, if the CBT exam will be in December, then obviously maybe after 1 or 1.5 months CBT2 will also be conducted. Okay, so if you guys will not take this seriously, then this railway notification which came exactly after 5 years or 5.5 years, then those who are going to not prepare it seriously, they are going to lose their chance of getting selected in RRB JE. Okay, so please seriously prepare for it, whether it is CBT1 or CBT2, because CBT1 is just the first step. After CBT1 you have to also give CBT2. So good evening everyone, once again welcome to this session and welcome to this platform of Resultant. I hope you have subscribed to this platform of Resultant. If not, then please do it and also press the bell icon after subscribing this channel. Okay, also do not forget to like this session. If you find that the session is definitely helping you for preparation, then do hit the like button and share the session also. My dear students, a short introduction about myself. I'm just I hope you guys know that I'm Vikas Sir, faculty of mechanical engineering, having over 7 years of teaching experience. I have taught these subjects from the last 7 years and some other subjects also, but these are the subjects that are common for all the exams, and I'm a faculty of these subjects, especially have expertise in this subject. I have done my MTech in thermal and fluid engineering. Basically, that's why these are my expertise subject also, and mentored more than 1 lakh students for these exams. Coming to question number 1, I will not be taking much time of yours, and I request everyone to quickly share this session because the number of students is so much. I'm so happy to see that 2 students are live in the session even after receiving the tentative schedule of RRB JE. At least now the students should be serious. Now at least the date is also fixed. Now prepare for it. Okay. So the exam date is fixed now. You have got less time. Rankine cycle with temperature limit of 400 and 1200 employs a turbine which produces a net work of 1300 and pump consumes a work of 15. What is the second law efficiency for this plant if heat addition is 2600 kilojoule per kg? How to find the second law efficiency? First of all, how to find second law efficiency? Second law efficiency is the ratio of actual efficiency to the Carnot efficiency. Carnot efficiency you can find if the temperatures are given. You can find the Carnot. It is 1 minus lower temperature by higher temperature. You can, because temperatures are given for this, you can find the Carnot. This is 1 minus 400 by 1200. Okay. So 66.6%. Okay, 2 by 3. Okay, now actual efficiency will be equal to net work divided by heat supplied. What is the net work? Net work is 1300 and pump consumes so it is turbine work minus pump work divided by heat supplied. So turbine work is given to you 1300, pump work is 15, divided by heat supplied is 2600. Solve it, you will get the actual efficiency. And just put in this relation, you will get the value of second law efficiency. Come on, everyone. So you will get 49.4%. Okay. So if you just put in this relation, you will get 0.494 divided by 0.66. You will get the efficiency. You will get 74.8%. So approximately you get 74.1. Are you all getting this value? Tell me. Hello Raj Verma, Neeraj, good evening. Welcome to the session. So this was question number 1, where we have found, we have calculated the value of second law efficiency. Okay. Good evening. Welcome to the session. Welcome everyone. So I'm meeting you after a long time. Guys, as you can see, the sessions are not regular now. The frequency has been reduced so that at least you guys should take these sessions seriously. Because regularly providing the classes also not made the students realize the importance of these classes. The students were still less. And even after taking 1 or 2 classes after every week, then also the number of students are 4. Do you want me to completely end these classes? So I don't want that. So that's why I want everyone to attend the session. Consider the following statement regarding reheat Rankine cycle. Reheat Rankine cycle. The main purpose of the reheat in the Rankine cycle is to increase the efficiency. This is wrong, as main purpose of reheat is to increase dryness fraction. Okay, the first statement is not correct. So this is not correct. So this and this will not be correct. Automatically you will get the answer as option B. In practice, what is the meaning of in practice? That is practically the reheat is generally limited to 1 point of expansion. What is the meaning of 1 point of expansion? So when you do reheating in the Rankine cycle, reheating is nothing but actually multi-stage expansion with reheating in the turbine. So firstly you do expansion, then reheat, again expansion. So practically we do 1 stage of expansion. This is 1 stage of expansion, then reheat. Because 1 reheat, if you perform 1 reheat, then efficiency increases by 5%. If you do 2 reheat, then also efficiency increases. After reheat, 2 reheat, efficiency decreases. So you don't need to do more than 1 reheat at least, or 2 reheat. Due to reheat, the steam rate is reduced, because reheating increases the net work. So if net work increases, steam rate which is equal to 3600 divided by net work. So if this increases, steam rate will reduce. Okay. Consider the following statement. Volumetric efficiency of a reciprocating air compressor increases with. We are talking about reciprocating air compressor. Okay. What is volumetric efficiency of a reciprocating compressor? That is 1 plus C minus C, P2 by P1 power 1 by N. This is the formula for volumetric efficiency of a reciprocating air compressor. Now, how the volumetric efficiency increases? With increasing clearance ratio? No. Because if you increase the clearance ratio, volumetric efficiency will reduce. This is wrong. Decrease in delivery pressure? Yes. If you decrease the delivery pressure, then overall pressure ratio will decrease, the volumetric efficiency will increase. This is correct. Multi-staging is actually done for increasing the efficiency. If you do multi-staging in the compressor, then multi-staging is actually done for this. Multi-staging is actually done for the purpose of increasing the volumetric efficiency and decreasing the. Multi-staging is actually done for this. Volumetric efficiency increases and work input reduces, right? So yes, this is correct. The right answer, this is wrong, so the answer will be option B, 2 and 3. Very good, Neeraj MS, very good. Next question. The suction pressure is 1 bar and delivery pressure is 125 bar. What is the ideal intermediate pressure at the end of first stage of a 3-stage air compression? So we have 3-stage air compression. This is first stage, intercooling, second stage, intercooling, third stage. So this is first stage compression. This is second stage compression. This is third stage compression. Okay. Now, it is also given the question that the suction pressure, this is suction pressure is given as 1 bar and delivery pressure is 125 bar. Delivery pressure is this. If this is P1, this is P2, this is P3 and this is P4. This is 125 bar. Okay. Clear to everyone? You have to find the intermediate pressure at the end of first stage. That is, you have to find this P2. So you know that for X stages of compression, let's say the number of stages of compression are X. For X stages of compression, the formula is Px plus 1 over P1 is equal to P2 by P1 power X, where X is number of stages of compression. How many stages are of compression? 3 stages. So X is equal to 3. So put the values here, you will get P4 by P1 is equal to P2 by P1 power 3. So P4 is equal to 125, P1 is 1, P2 by P1, that is 1 power 3. So this will be P2 will be equal to 125 cube root. So you will get 5 bar. Okay. You must be thinking, sir, what's the need for so much elaboration, so much getting into detail? Because maybe sometimes next time they can ask you the value of P3, find P3, or so how you will find P3? So you should know that in multi-stage compression, when ideal intermediate pressure is asked, then P2 by P1 is equal to P3 by P2 is equal to P4 by P3. The pressure ratio becomes same. So if they ask you the value of P3, you should know that P3 will be equal to P2 square into P1, that is 25 bar. Okay. Next time maybe they can ask you what value of P3. Next question. In a single stage reciprocating air compressor, the work done on air to compress it from suction pressure to delivery pressure will be minimum when the compression is. So basically, there are different ways by which you can compress the air. You can compress it by adiabatic process, you can compress it by polytropic process, you can compress the same air by isothermal process, you can compress it by polytropic process, and you can compress it by adiabatic process. Okay. So it's a pressure and volume diagram. You can do any of these compression. So which will be producing minimum work, or which will require minimum work for compression? Obviously, isothermal compression. The minimum work of compression will be isothermal compression. If the cross section of a nozzle is increasing in the direction of the flow in supersonic flow, then in the downstream direction. If the cross section of a nozzle is increasing in the direction of the flow. So firstly, they are saying it is a supersonic flow. Supersonic flow. And for supersonic flow, direction in the direction of flow, cross section means area is increasing. if area is increasing, in the direction of the flow is area is increasing, okay, that is here the area is A1, this is A2. So if A2 is more than A1, so this is called a divergent nozzle. This is called a divergent nozzle. Okay, so it will become a divergent nozzle for supersonic flow where Mach number is greater than 1. So if it is a nozzle, then what will happen? In a nozzle you get pressure reduced and velocity will increase. So pressure will decrease, velocity will increase. Option D will be the answer. Next, in the power plant, the efficiencies of electric generator, turbine, boiler, thermodynamic cycle, and overall the plant, all these efficiencies are given. Okay, everything is given. The total electricity generated for running the auxiliary will be all. Basically, there are different components in the power plant. You know that in the power plant we have many components. So we have generator in the power plant, turbine in the power plant, boiler, and thermodynamic cycle and overall plant cycle efficiencies. So basically the generator efficiency is given, which is 0.97. Turbine efficiency is given, which is 0.95. Boiler efficiency is given, which is 0.92. Cycle efficiency is given 0.42 and overall efficiency is given, which is 0.33. How to solve this question? How to solve this question? You have to find the total electricity generated for running the auxiliary. Yes. So overall efficiency will be equal to efficiency of generator into turbine into boiler into cycle into auxiliary. We'll also multiply with auxiliary. So just put everything, you will get this is 0.33 is equal to 0.97 into 0.95 into 0.92 into 0.42 into efficiency of the auxiliary. So you will get efficiency of the auxiliary from here. But you don't have to tell the efficiency, you have to tell the electricity generated for running the auxiliary. How you will solve it? So you will get efficiency of auxiliaries. How much will be the efficiency of the auxiliary? 0.926. So auxiliaries are 0.926, 92.6% efficient. So what is the total electricity generated for running auxiliary? Tell me. Running auxiliary, that will be 1 minus 0.926, right? So you will get or 100 minus 92.6, so you will get 7.3%. If you want to find percentage, it will be 7.32. Okay. If the inlet temperature to compression and turbine are given, inlet temperature to compression turbine are given as this, then efficiency of an ideal regenerative cycle for a pressure ratio of 6 is approximately equal to. So we have a gas turbine cycle. Ideal regenerative efficiency of a gas turbine cycle is 1 minus T1 by T3 pressure ratio of gamma minus 1 by gamma. This is a formula for efficiency of ideal regenerative Brayton cycle. 1 minus T1, what is T1? 300. What is T3? 1260 into pressure ratio is 6 1.4 minus 1 by 1.4. Solve it, you will get the answer. This is a direct formula for efficiency of an ideal regenerative Brayton cycle. So you will get, when you solve it, you will get 60.3%. That is 60%. Okay. You need to figure out that they are talking about Brayton cycle. They are talking about which turbine, because they are talking about compressor. Which turbine will be having compressor? Obviously, they are talking about gas turbine. Okay, without any doubt. In an impulse turbine, the tangential velocity of the steam at root radius of 200 mm is 420 meter per second. If the blade height is 120 mm, then tangential velocity at the tip will be. So how are you going to solve this question? Yes. Now you guys try to solve it. I'm giving you some time. And if you're not able to solve it, obviously I will explain it. I think many of students have got so much serious about this, that RRB JE notification. They are thinking that they will only study for CBT 1. Okay, solve it. No idea. Okay, no idea. How to solve this question? The tangential velocity of the steam at root radius is 200 mm. 200 mm is 420. That is. So, do you know that they are talking about tangential velocity? You know that tangential velocity is equal to omega into r. Okay. This is one relation that we use for tangential velocity. So we can say that it is directly proportional to radius somehow. So you can say that u1 by u2 is equal to r1 by r2. You can use it because they are asking about both tangential velocity, and tangential velocity is nothing but it is related to the angular velocity like this, u is equal to omega into r, right? So u1 is equal to 420, u2 you have to find, r1 is equal to 200, and blade height is 120. Now, but they have given the blade velocity, blade height. They have not given the radius. So just let me check. Yeah. So what will be the outer radius? R2 radius will be equal to R1 plus H, blade height. So that is 200 plus 120. It will be 320. Okay. So 320 mm will be R2. This is 320. Now I guess you can solve it. Okay. You will get U2 is equal to 420 into 320 divided by 200. This will get cancelled. This will get cancelled. 2, 16. So it will be 42 into 16. Solve it, you will get the answer. Okay. This is also important question. Can be asked in some exam. So you will get 672 meter per second. Okay. Is it clear to all of you? Understood this question? Next question. Assertion reason based question. In a gas power turbine, the efficiency of the cycle is 0 when the pressure ratio is unity. Reason is, in a gas turbine cycle working on simple Brayton cycle, efficiency of cycle becomes 0 when it is having a maximum pressure ratio. First thing you are saying that efficiency of cycle is 0, efficiency of a Brayton cycle is 1 minus 1 by pressure ratio of gamma minus 1 by gamma. Okay. Now they are saying that efficiency of the cycle is 0 when pressure ratio is unity. So if pressure ratio is 1, then they are saying efficiency will be unity, that is efficiency will be 100%. Is it so? Yes. Now what reason they have given? If pressure ratio is unity, then in that case the efficiency will is 0. They are saying efficiency will become 100%. Efficiency will be 100% or 0? 0. Yes. So this is correct. In a gas turbine cycle on simple Brayton cycle, efficiency cycle becomes 0 when it is having maximum pressure ratio. When pressure ratio becomes maximum, then efficiency of the Brayton cycle becomes equal to Carnot cycle, and it also becomes maximum efficiency, not 0 efficiency. So this is wrong, this is right. So assertion is true, reason is false. Okay. The temperature limits in a Brayton power plant are 400 and 1600. If the index of working medium employed is 1.5, then calculate the optimum pressure ratio for maximum work. Optimum pressure ratio for maximum work in the Brayton cycle. What is the formula for optimum pressure ratio in the Brayton cycle? Optimum pressure ratio is T3 by T1 gamma over 2 gamma minus 1. Here is the formula. Just put the values. T3 is 1600, T1 is 400. These are the temperature limits. Gamma is 1.5 by 2, 1.5 minus 1. Okay. 4 power 1.5. Solve it. Okay. So the answer will be option D. All right. Next question is, there are two statements. Statement number 1, thermodynamic work is given as product of an intensive thermodynamic property and differential of an extensive property. Thermodynamic work is, what is thermodynamic work? So thermodynamic work or non-flow work is PDB work. It is product of intensive, this is intensive property, pressure is an intensive property, and volume is extensive property. So it is basically the product of intensive and differential of extensive. This is correct. Work is not a thermodynamic property. Work is not a thermodynamic property. So these two statements are correct. Work is not a property, correct, and thermodynamic work you get by multiplication of these intensive and extensive property. Both the statements are correct. But is this option number B is explaining this? No, it is not giving any correct explanation. It is not giving any explanation that it is not a thermodynamic property. Work is not a property because Work is a path function. Work is a path function. Okay, not a point function. And properties are point function. Okay, so they have not given the reason for it for the first statement, that they are simply saying work is not a thermodynamic property. So both are not related. Both are true, but both are not related. In Rankine steam cycle, steam is expanded in turbine from enthalpy of 3514 to 613. If thermal efficiency of cycle is 38%, heat added in the cycle is. How to find the heat added in the cycle? Efficiency of the cycle is equal to net work divided by heat added. Efficiency is 0.38. Net work is turbine work minus pump work divided by heat supplied. Pump work is already given, turbine work will be 3514 minus 613. Pump work is 10. Just solve it, you will get the answer. So heat supplied will be equal to so you will get 7607.89. No option is 76. No option is exactly closer to this. 3514 minus 613 minus 10 divided by, yeah. So only option that you can approximately take 7634 as the answer. You have no other options. Okay. So you have to take approximate value of option C. Right. A 4-stroke diesel engine has a length of 20 centimeter and diameter of 16 centimeter. The engine is producing power of 25 kilowatt. When it is running at 2500 RPM, the mean effective pressure of the engine will be nearly. How to find the mean effective pressure of the engine? If you don't pump work, answer. Okay. Okay. So basically you are saying that if you neglect pump work, see, either they have not, why they have given pump work then? Then 0.38 is equal to 3514 minus 613 divided by heat supplied. Then you will get heat supplied as, you are saying, 7634 only. So I think we have to consider pump work if it is given. If it is not given, then we can neglect it. They have given the pump work 10 and then they are neglecting it. So no problem. I have told you how to solve the question. If you neglect it, then also you will get the answer. And not then approximately you have only one option, which is closer to 7607, which is 7634. A 4-stroke diesel engine has a length of 20 centimeter and diameter of 16 centimeter. The engine is producing power of 25 kilowatt. So how to solve this question? So if the power is given and you have to find mean effective pressure, you can use brake power as brake mean effective pressure into LANK by 60. You can use this formula. There is no other option because mean effective pressure and power, they are related by this formula only. Number of cylinder is 1, K will be taken as 1. This is number of cylinder. And because they are talking about brake power, even for 4-stroke engine, that will be taken as N only. Okay. So 25 and divide by 1000. if you divide 1000, then you will get kilowatt. 25 kilowatt is equal to, or you can, if you don't want to divide by 1000, it's fine. You can simply put 25 kilowatt as watt into 1000 in watt, brake mean effective pressure, into L. L is stroke length is 20 centimeter, that is 0.20 meter, and area will be pi by 4 into d square, 0.16 square into stroke length is, sorry, RPM is 2500 divided by 60. Solve it and tell me the answer. I guess we don't have to use n by 2. I think there's some issue in this question. We are not getting the exact value. Are you getting the answer, everyone? Have you tried? Got some result? Okay, you have to take n is equal to n by 2. Although in brake power calculation, we don't use it, but I think for this question we have to use it. We have to use n is equal to n by 2. N is equal to n by 2 we have to use, yes. So we have to use this n is equal to n by 2. अब you must be thinking, sir, why are you using n is equal to n by 2? कौन सा कैलकुलेटर अलाउड है सर? No calculator is allowed for Neeraj, no calculator is allowed for your exam. It is virtual calculator. Virtual calculator is allowed, which will be provided in your computer screen. Okay, so you don't have to take your own calculator in the exam. Virtual calculator is provided in the exam only. There will be a computer in which you have to mark your options, and there will be a calculator which is called virtual calculator, like in the GATE exam. So you have to use for 4-stroke. Here you have to use n is equal to n by 2 for finding the brake power, because this formula is different. Okay, here you have to divide by 2. When you do this, you will get brake mean effective pressure as 2.98 bar. Okay, are you all getting this value, 2.98 bar? Solve it, give, I think you will get the same answer. Next question. A 4-cylinder and 4-stroke petrol engine develops an output of 44 kilowatt. If the pumping work is 5% of indicate work and mechanical loss is an additional 7%, then power consumed in pumping work is. Pumping work, what do you mean by pumping work? What do you mean by pumping work in engine? So pumping work is basically, in the engine there are some operation like suction and exhaust. For these operation, the work which is required, the power which is required power required for suction of charge and exhaust of gases, that is called pumping work. Okay, and how you get the power for this? This power is actually part of indicate power only. Okay, the power which is required for pumping is actually we derive from indicated power only. Okay, so pumping loss is, how much is the pumping loss? Pumping loss is 5% of indicate power. Okay, that is 0.05 of indicate power. And mechanical loss is additional. Mechanical loss will be from which power? Which power required for mechanical loss? That is, mechanical loss is frictional losses, which is 0.07 of indicate power only. Okay. So what is formula for brake power? Brake power is equal to indicate power minus, actually these pumping and mechanical loss, they both come under frictional loss of friction power. What is the formula for brake power? Brake power is equal to indicate power minus friction power. And this power consumed in pumping and mechanical losses, that is actually friction power. So this is 0.05 of indicate power minus 0.07 of indicate power. Solve it. You will get indicate power minus 0.12 of indicate power, or you will get 0.88 of indicate power. What is brake power? The brake power is 44 kilowatt. Okay, the brake power is 44, so indicate power will be equal to 44 by 0.88. So from here you will get indicate power, which is 50 kilowatt, but you are interested to find the power consumed in pumping. What is the power consumed in pumping? The power consumed in pumping loss or pumping, that is 0.05 of indicate power. Okay, which will give you 2.5 kilowatt. 2.5 kilowatt. Clear? So mechanical loss and pumping work both are actually indicated friction power. And how the friction power is basically the power which is taken from indicate power only in order to overcome the pumping and mechanical losses. Okay, which of the following statement is true? On a PV diagram, the triple point is a line and critical point is a point. On a pressure temperature diagram, both triple point and critical point are points. Both are correct. If you ask which is correct, both are correct. On a PV diagram, if you see a PV diagram, so if you have to show triple line, so this will be the nature of the curve. So here triple line, this is triple line. Triple line is a line and critical point is a point on a PV diagram. While if you see a pressure temperature diagram, on a pressure temperature diagram, triple point and the critical point both are points. So this is your triple point and this is your critical point on the pressure temperature diagram. Okay. A throttle governed steam engine develops 13 kilowatt with 280 kg power of steam and 35 kilowatt with 520 kg power per hour. Sorry, it is per hour. kg per hour of steam. The steam consumption in kg per hour when developing 20 kilowatt of power will be nearly. Yes, Ais, how are you going to solve this question? So, you know a curve which is known as Villen's line curve, which is also plotted for a steam engine. In this curve, we plot a curve between mass of the steam consumed and indicated power. The curve is somewhat like this, and the equation of this curve is mass of the steam consumed is equal to, this is A, okay, and this is B into indicated power. That is the slope. That is, you will get, this is B actually. B is the slope. It is A plus B into indicated power. So this is the equation of this curve. This is A, this is constant, B is the slope of this curve. So first equation is when mass of the steam consumed is this much, then power is 35, equation number 1. Secondly, when the mass of the steam consumed is 520, then the power is, so firstly it is 13, right? 13, when it is 13 kilowatt, and then it is 35, equation number 2. Now from equation 1 and 2 you need to find the value of A and B. Okay, find A and B and then put in this equation mass of the steam that is required to produce power of 20 kilowatt. So if you know A and B, put it in this equation, you will get the answer. Understand everyone? So you will get B as 10.909 and A as 138.2. So you will get this as you will get this value as 356.38 kg per hour. Are you getting this value? But this is not close to any of this option. Only option that is close is approximately 340. Right? Only one option is closer to the options given. Cannot be calculated, cannot be the right answer, because yes, it can be calculated, but approximately you will get 340 as the answer. The combustion phenomena in a CI engine can be divided into 4 stages. So basically in the diesel engine, the combustion happens in 4 stages. Which of the following is the correct sequence of these 4 stages of combustion? What are those 4 stages? Afterburning, controlled combustion, uncontrolled, controlled, and ignition delay period. So you know that firstly in the diesel engine, the first stage is ignition delay. Then we have uncontrolled combustion, where detonation takes place in the diesel engine. Then we have controlled combustion. Whatever fuel is left and air is left, it burns under controlled combustion. And the last stage is afterburning stage. Okay, so this is a sequence of stages in the diesel engine. So this will be D, then after that B, then after that C, and after that A. So DBCA, that is option B. Very good. Next question. Which of the following is not correctly matched? Which of the following? See, I am going to take the class only till 10 p.m. So request everyone to please be with me till 9 more minutes. Okay, for 9 more minutes and then the class will be over. But if you guys try to leave the session like this, See, I have told you very frankly that I know that there are so many options for you to study in the YouTube. There are so many free channels. But if you believe that I give you some quality questions, some concepts, if you find these classes useful, then I request not to miss this session. If you not attend these classes, not participate in the classes, then the frequency of the classes is reduced. It will be further reduced. Which of the following is not correctly matched? Internal efficiency of the steam turbine is product of stage efficiency and reheat factor. Stage efficiency of a turbine is ratio of adiabatic heat drop to isentropic. This is correct. Dryness fraction of steam within a stage decreases due to reheating. Dryness fraction decreases due to reheating. This is not correctly matched. Dryness fraction increases due to reheating. Okay. So this is wrong. This is wrong. This is because reheating increases the dryness fraction. A closed system of constant volume experiences a temperature rise of 20 degrees Celsius when certain process occurs. The heat transfer is 25. A specific heat at constant volume is 2. System mass is 2 kg. Determine the work done. We'll use the formula Q minus W is equal to du. Right? Heat is given 25. Du, you know that it is equal to mCv dt. So 25 minus work is equal to 2 into Cv, that is 2 into 20. Okay, so 25 minus work is equal to 80. You will get work from here. What is the value of work you are getting? Yes. So you will get minus 55 work. Okay, work will be negative here. So minus 55 will be the answer for this question. Next question. Which of the following are effects of nozzle friction? The friction in the nozzle, right, has many effects. Enthalpy drop decreases because of friction. Yes. Exit velocity reduces. Yes. Decrease in the specific volume. Decrease in the mass flow rate. A specific volume is not going to decrease. It is increases. So this is wrong. Decrease in mass flow rate. Yes. 1, 2 and 4. Which of the following are effect? 1, 2 and 4 are the effects of nozzle friction. Consider the following statements. Octane rating of gasoline is based on isooctane and isoheptane fuel, which are paraffins. Not isoheptane, that is wrong. It is N-heptane, not isoheptane, it is N-heptane. That is called normal heptane. Tetraethyl lead is added to gasoline to increase octane number, correct. Ethylene dibromide is added as scavenging agent to remove lead deposit on spark plugs. Surface ignition need not necessarily cause knocking. Which of the following are correct? This is correct. Surface ignition not necessarily cause knocking. This is ethylene diamond is C. The first option is not correct for sure. So this and this cannot be the answer. The answer is option B. 2, 3 and 4. Very good. Consider the following statements. Just a second. A decrease in the evaporator temperature of a vapor compression machine leads to vapor compression machine. Okay, the evaporator temperature is decreased. evaporator temperatures decrease in the vapor compression machine. So this is vapor compression machine. The temperature of the evaporator has reduced. Okay. So if the temperature of the evaporator will reduce, so this work input will increase, refrigeration effect will decrease. Okay. Because of that, volumetric efficiency will, what will happen? It will decrease. Okay. Increase in refrigeration effect? No. Increase in specific volume of the vapor, decrease in the volumetric efficiency, and increase in the specific work. Okay. Now, this is correct and this is correct. That is 3 and 4 are correct. There is no other option. We have to mark increase in specific volume of vapor. That is 2, 3 and 4. 2, 3 and 4 will be the right answer. Okay. In a boiler, feed water supplied per hour is 225 while coal fired per hour is 25. Let's solve one question from boiler efficiency also. I hope you guys have not forgotten the formula. Efficiency of the boiler is mass of the steam which is produced into delta H, which is enthalpy of the steam which is produced minus enthalpy of the feed water which was used for producing the steam. If you see the difference of these two, that is delta H, it is also called rise in the enthalpy, divided by mass of the fuel into calorific value of fuel. So mass of the steam is how much? 25. Enthalpy rise is 150. Mass of the coal is water supplied is 225 kg. 225 by 25 into 150 divided by 2050. Okay. What will be the answer? 65.85. Okay, let's check it. 225 divided by 25. Okay, so you will get 65.8, 66%. Next question. A Carnot cycle operates between temperature of 300 and 2000, produces 600 kilowatt of net power. The rate of entropy change of the working fluid during heat addition process. How to solve this question? So you know that it is a Carnot cycle. The efficiency of the Carnot cycle is 1 minus 300 by 2000, which is equal to work by heat supplied. So from here you will get the value of heat supplied. So heat supplied will be equal to work is 600 into 2000 divided by 1700. You will get heat supplied from here. Entropy change during heat supplied is equal to heat supplied divided by temperature at heat supplied. Right? This is the last question for today's session. 600 into 2000 divided by 1700. So you will get 705.88 kilowatt as a heat supplied. So divide by heat supplied temperature. So you will get 0.352 kilowatt per Kelvin. Okay, option C. This is also one question. Let's take this as our last question. In an Otto cycle, temperature before adiabatic compression and end of adiabatic compression are given. That is T1 is given in the Otto cycle 27, T2 is given 527. Temperature before beginning expansion, that is T3 is 1127. Find temperature at the end of expansion, this is T4. How to find T4? Yes, I hope you guys know that there is something about the Otto cycle that you guys should know. That in Otto cycle T2 by T1 is equal to T3 by T4 is equal to tell me, V1 by V2 gamma minus 1, that is compression ratio power gamma minus 1, that is T2 by T1 is equal to T3 by T4 in the case of Otto cycle. So just apply this, you will get T4. So just convert this into Kelvin. This will be 1400 Kelvin, 800 Kelvin, 300 Kelvin. Okay, you have to get the answer in degrees Celsius later on. So you will get T4 as 525 Kelvin, which is 252 degrees Celsius. Okay, that's the last question. Thank you so much for joining me for this session. Now my next class will be on 9th October. My next class will be on 9th October. Okay, 9 p.m. on fluid mechanics. Fluid mechanics, most important question. Okay, so I'm going to see you on 9th October for this topic. Do not forget to like and share the session and subscribe to our YouTube channel if you have not done yet. Thank you so much for joining me for this session. And as you know that tentative dates for RRB JE exam, ALP exam is out. So please prepare for it and be ready for it. Don't leave any stone unturned because the time is very less. Opportunity एक बार आती है दोबारा नहीं आती है. It will take a lot of time. 8 p.m. it's not possible for me because I have to take a paid course I'm taking fluid mechanics subject for GATE and ESE right now, and that paid course is from 6:15 to 8:15. Not possible to take the YouTube at 8 p.m. That is why the timing has been changed to. If you want to suggest any other timing apart from 9 p.m. you can suggest me. I will take the class at any other timing except if you want the class in the morning, I will take the class in the morning. If you want me to take the class and at 1 p.m. I will take 1 p.m. So you can tell me at any other timing if you want me to take the class. Okay. 4 p.m., 5 p.m. any. Okay, you want me to take class at 4 p.m. or 5 p.m.? That is also possible. I can take the class at 4 5 p.m. Okay. Okay, thank you so much. Bye bye. Take care. See you tomorrow. Thank you so much.